Okay, so let's look at another question that involves the binomial distribution. Now, binomial, bi coming from two, means when you have two choices. So it's either success or failure. So when we have a question, we don't necessarily know that it's going to be binomial distribution. So we have to look at the question first and then decide. So the question is, in a certain country, the average on average, 1 in 5 students has blue eyes. Okay, so 1 out of every 5 have blue eyes. So I have blue eyes. So if we would take a random sample, it's likely that the other 4 people in a group of 5 would then have another color eyes. It doesn't say brown or green, or it only has blue or not blue. So that's the thing with binomial. It's either one thing or the other. So this is binomial because you've got blue eyes, and then just not blue, right? Not blue. So this little dash, we can just indicate that that's not blue. All right, so what are our things we have to know in a binomial distribution? So we've got to know what our P is, right? Our P is our chance of success. So let's make our P green. So that's our success. So 1 out of 5. So we're going to be successful 1 out of 5, which is 0.2. So that's our success. So then our Q is the not successful. So let's do that in red. And so that's just going to be 1 minus 0.2, which is 0.8. Okay. Now you don't have to do this every time. This is just going to be instructive for our intents and purposes of this question, is just to also be able to answer any type of question that you might not get, not just this specific question. So then if we look, what is our N? So our N is our number of students in our population that we choose. Well, we don't know what that is. That is what we have to find out. Okay. And so normally what we do is we work out our probability. Our probability. So in this case, though, we've given our probability. So our probability so by the way, this is little q. Let me just make that a bit clearer. Our P, these P chance of success is lower P, is small p and small q. So let's do that, because in case we need to now give the probability, which is a big P. So we don't want to get those mixed up. So let's do that. And let's make that, that's clearly, you want that to be a, so we don't know what our, we actually given, sorry, we're given our probability as being equal to 0.01. Okay, so 0.001. Okay, the probability that none of the students have blue eyes, right? None have blue eyes. So if we were picked a bunch of students, none of them would have these blue eyes. So, you know, we could have hazel eyes, we could have brown eyes, you know, and we get all these students together, some with green eyes. But we don't want any with blue eyes. So as soon as we get a blue eye, that messes us up, because we want the probability that there's no blue eyes. So basically what we want is these, we know that the blue eyes was the 0.2. And then all of these here, the not blue eyes, are the 0.8s. And so we want just 0.8s. So what we would do is then for our, if we were to work out the probability of all of these 0.8s here, right, it would be 0.8 times 0.8 times 0.8 all the way until we got a blue one. So we're not allowed to have a blue one. So if we think about it, we would have to have 0 blue eyes. So there would be 0.2 we couldn't have. So it would have to be the 0.2. Now, when we look at the binomial theorem, 0.2 to the power of 0, because there would be none, would be 0. Actually, let me do that in the next line. So there's going to be, we don't actually have here, we don't have the blue eyes in here. So there's no 0.2. Okay, so now if we imagine that we don't know how many N's there are, how many I's there are, so this would just be 0.8 until we get to a blue. So it's 0.8 N because we don't know. So that is our N. Our question mark is like, how many N's would we get to? And so that would be fine. But then our blues, we must have no 0.2. So I'm going to put, instead of 0.2, instead of not putting anything, I'm going to put 0.2 to the 0, which is 1. So basically, when we times something by 1, it doesn't change, right? 10 times 1 is still 10. So just to be mathematically correct, I'm putting 0.2 to the 0 because I wanted it to sort of look like the binomial theorem, which is how many we would choose. And so this bit here, so in your memo, what you would probably see, like if this is an exam question, in the memo, you would probably see this without the 0.2 to the 0 and without the, what I'm going to do now, which is the N choose N, which is how many I choose. Now this N choose N is also just 1. And so that's not going to change it either. So you won't see it there. But thinking about it like N choose N, let's say that it was 10, we were able to choose 10 not blue eyes. And of course, we don't want any blue eyes. Well, 10 choose N, when we write that, when we write this out, what that means is 10 factorial over this 10 factorial, and then 10 minus 10, which is 0 factorial. So if you don't understand this equation, in fact, let me just explain this N10 choose N equation. So if you already know about this, skip. But I've done it in a few lessons. So I'm going to just explain this part of the binomial formula. So what you'll notice, let me just write out the binomial formula again for those of you who didn't. So if you already know the binomial formula, just skip through to the end. But let me just explain the binomial for those of you who are watching for the first time. So the binomial formula goes N choose, and then what the number of people that we choose. So it could be, say we choose, I don't know, let's call it K. So K is the number of people you choose out of the population. Times P should be N so let's make that K times Q to the N minus K. Okay, and then I'm going to go over this in the colors that I've done. So the green and the red is the Q. Now this K, it gets called different numbers, but different letters, but the K just means how many people are we choosing in order, how many people from the population are we choosing? And then N is the number of tests. So we'll do that in orange. Okay, so you'll see this formula. And what you could say is that, so let's just examine this formula. This P is your probability of success, and Q is the probability of not success. Then N is the number of trials or number of times you perform the test, and K is your number of successes. So that would be then to the power of. So let's look at how this would then work with the I example that we've just done. So let's say that it wasn't, let's say that this question was different in that they'd asked you out of 12 students. Actually, no, let's use our example up here. We've got 1, 2, 3, 4, 5, 6, 7, 8 students. So let's say that we chose from 8 students and they asked the probability that one of them has blue eyes. So then it would be, you would write 8, choose 1. And then you would look at the P would be your probability that's a student with blue eyes, which is the 0.2 blue eyes. And there's one of them. You see there's one of them there. Okay. And then we multiply that by Q, which is the probability that it's not blue eyes, which is 0.8. And then you notice this N minus K, which basically means 8, is 8, minus K, which is 1, which when 8 minus 1 is 7. Well, that makes perfect sense. Because you notice that there are 1, 2, 3, 4, 5, 6, there were 9 eyes. So this should have been 9. Okay, so what I'm going to do is delete. Let me delete one of these eyes. 1, 2, 3, 4, 5, 6, 7. Oh, no, there were. I just wrote the 0.8. So there are 1, 2, 3, 4, 5, 6, 7, 8 eyes. Yeah, that's fine. Okay, so we've got the red are the not blue eyes. The 0.8 to the 7, and then the 0.2 are the blue eyes, and then we'd say 8, choose 1. Now the reason for this 8, choose 1 is because let's say that you picked everyone from the beginning, and so you said, well, let me check the first guy. First guy has blue eyes, which means all the other 7 would have the not blue eyes, but the second person could be the one who has blue eyes, or the third person could be the one with blue eyes. And so there's more than one combination when you get them in order of people of one person having blue eyes. And so that is what this bit is here. This bit here, oopsie, this bit that's why it's a C, because it actually means combination. There are a number of different combinations of ways in which you could get blue eyes. So let's look at how that would be written out a long way. So you have a button on your calculator which does this, but let's look at the factorial part, and then we'll get back to this original question. So we have 8, choose 1. Now what that means is 8 factorial on the top over, and then we're choosing 1, so we say 1 factorial. By the way, 1 factorial is 1 because it just means 1 times 1. 0 factorial, interestingly, is also 1, because if you put a 0 at the bottom, we would get as that would be undefined. And so you'd get a math error. So that's why 0 factorial we need at the bottom. We'd have to put a 1, not a 0. Although if you do write 0 factorial in your calculator knows that that's 1. And then you say the bottom is the 1 and then the 8 minus the 1. So remember, there's always two things on the bottom. There's the 1, and then whatever this number is, this in this case 8, minus the 1, which would be a 7 factorial. Okay. Now what I want to do is I want to write this out again in long ways. So for those of you who don't know what factorial means, it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1 is that bit. Blue. And then the 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now watch, we can cancel. So let's look at what we can cancel. The 7s cancel, the 6s cancel, the 5s cancel, the 4s, the 3s, the 2s, and the 1s all cancel, leaving us with 8 times 1 at the top and 1 at the bottom, which is just 8. Okay, now, so the answer is 8. Well, that makes sense because there were 8 people. So in this kind of example that we did for ourselves to explain what this means is the first student could have blue eyes, or the second, or the third, or the fourth, or the fifth, or the sixth, or the seventh, or the 8th person could have. So there were 8 different ways where you could have 8 students and one of those 8 students having blue eyes. And so that is what this 8 combination means. And then here, this bit, well, that's the 1 student who has the blue eyes, and then the 7 that have the not blue eyes. Okay, so that's just what this NCN means. And as I say, in this memo for this question, this NCN is not going to be there because it's going to be 1. And let's look at why. Because it's N, and then you are essentially choosing, well, we could either say, so, well, actually, let's do it. So we've got the 0.8 here to the N, and we've got the 0.2 to the 0, which is 1. Now let's do this bit here. Well, it would be N, choose, well, let's say 0, because we're looking at the probabilities of success, so no blue eyes. Well, if we were to write this out longhand as we did here, this would be then 0, so it would be the N factorial over the 0 factorial, which is the choosing no one with blue eyes, and then N minus 0. Well, what's N minus 0? Well, 10 minus 0 is 10. Anything minus 0 is just whatever it was. So it's the N factorial. And so we notice the N factorials cancel. 0 factorial is 1. And so we just get 1. And so if you were to look in your memo and see just 0.8 to the N, well, that's simply because this bit is 1 and this bit is 1. So in understanding the full binomial formula, this makes this question quite simple because you don't need the 1 and the 1. But it's important that we know the binomial because they're not always going to be this simple. And so that probability ends up being 0.01. So this formula where the probability is equal to this here, that's if you were to write the full formula. Okay, now the selection, find the least possible value of N, right? So the smallest possible value of N. So if we were to pick this up, if we were to say get our N to be, let's say this answer comes to 8.7. Well, if you got to 9, then we are looking at that 9th person would have a 0.2. So we're actually going to round down from whatever value, because this is not going to give us just a simple value for n. It's going to give us probably like a number with a decimal. Okay, so let's use our logs. So we can get our calculator here, and we're going to say log. So just for simplicity's sakes, this is 0.8 to the n, 0.001. Okay, so the least value, right? So log base is 0.8. The number is 0.001. So you should have a button on your calculator for this. If you don't, log laws, you can say log 0.001 over log 8. And what do you get when you put this in your calculator?
20.637.
Okay. 20.067. Is that right?
No, there's no 0.
So 20.67.
64637.
Okay, it doesn't matter too much about the decimal. We do have to write it in. Okay, so let's say that we were to have 21 people. So let's just put this 21 into the calculator. So what is 0.8 to the 21? It's going to be less than 0.01, right? Oh, so actually we're going to round up. What's 0.8 to the power of 21?
It's 9.22.
Times 10 to the something.
Yeah.
Okay, it's going to be 0.009. Did you say 22?
Yeah.
Okay, so let's look at that. Is that probability less than 0.01? Yes, it is, right? Does that make sense? You see, because 1 is 0.00. So what is 0.8 to the power of 21 equal? So we do round down, as I said here. What's 0.8 to the power of 20?